Hey guys, welcome. Okay, yeah, so 131st installment in our fun challenging integrals video series. A really cool fun integral just like the rest of them, so check them all out. Yes, there are gaps, but we'll fill in the gaps in due time. Yeah, okay, but yeah, check out all the videos in this series because they're all really fun. Alright, so how do we start here? Well, if we let x equal 1, so when x is equal to 1, the integral we're looking at is simply 0 to 1 of negative dx. Whereas if x is equal to, say, half, then the integral we're looking at is, when x is equal to half, we have 0 to 1 of negative 1 to the half power, so that's the square root of negative 1 dx. We see, so, complex integration versus real integration. So in the most general cases, we should do complex integration. That way, we take care of all of these situations, right? For all the values of x. Okay. So how do we do that? Well, I have a video on this. Check it out. But we know that cosine theta plus I times sine theta is equal to e to the I theta. So yeah, I have a video showing why this is true. It's easy enough to show, so check that out, but this is true. So we know that if theta is equal to pi, that this would read cosine of pi plus I times sine of pi, and that would equal e to the I pi. Like I checked myself out right now in this moment in third person. Like I stepped out of my body and was examining what I was doing, and that was like funny to me, and it was a real inside joke, but like I wanted to share it with you. Okay, anyway, yeah, when theta is equal to pi, we have this, and we know that, like, since cosine of pi is negative 1, but sine of pi is 0, that this left-hand side is negative 1. So what we have is negative 1 is equal to e to the I pi. That is, e to the I pi is equal to negative 1. All right. Now, what I just wrote is an all-familiar guy in disguise. You know, the so-called beautiful equation that has us write e to the I pi plus 1 is equal to 0. Right? This here is the same thing as this here. It's just from this we have subtracted negative 1. Well, sorry, no. We've subtracted 1 from both sides. Or we've added negative 1 to both sides of this. However you see it, it's easy to see that this is same as this. And this is the so-called beautiful equation because, well, it's got all the important numbers, 0, 1, pi, I, and e, if I may digress. Well, I asked that a little backwards, but did you have a choice? I don't know. Okay, but yeah, all I'm saying at this stage is that, like, you should know e to the I pi is equal to negative 1. But it's just not, it's not just at pi, English lessons. It's not just at pi, but at pi plus 2n pi, where n is an integer, that we have e to the I theta equaling negative 1. Okay, so if I said that a little too fast, I'm saying, yes, e to the I theta is equal to negative 1 when theta is pi, but e to the I theta is equal to negative 1 whenever theta is pi plus 2n pi, where n is an integer. For example, if n is equal to negative 1, then pi plus 2n pi would be pi plus negative 2 pi. That's negative pi, so theta would be negative pi. And I'm saying e to the I times negative pi is equal to negative 1. And obviously there are infinitely many values, so I'm not going to check all of them. All right, but this here then is telling us that e to the I times pi plus 2n pi is equal to negative 1. Now, in fact, in this part I can factor out a pi if it's easier on the I. Okay. so silly, to n. And I could write this here, and that's just as good, right? Okay, so one useful fact, another useful fact, right? Okay, and so then we're ready to do our integral now. You've got all the necessary tools. So the integral is the same as 0 to 1. Now, -1, we just labored to show, is equal to this left-hand side. So in place of -1, I could write e to the I pi and 1 plus 2n. And what I just wrote right here, this is -1, so long as n is an integer. But we've written that, we've said that n is an integer, so we don't need to write it over and over, is what I'm saying. Okay, so we've got -1 to the x. All right, so like that. And now, using exponent rules, we could write that what I just had is the same as writing the x right there, right? And of course, dx. Now, when you're doing complex integration, the integral of e to the az dz is equal to e to the az over a plus c, where a is a complex constant. And this here is like the a, it's a complex constant, because, well, I is a constant, although it's a complex constant, pi is a constant, and 1 plus 2n is a constant for a specific choice of n, right? Okay, so the variable is x, and if I could write a z there, it doesn't matter. It's implicit that we're doing complex integration, right? Okay, so this is just the same for real integration, right? If I have e to the ax dx, the result would be the same with the z replaced with an x, and yeah, okay, yeah, okay. So what I'm saying is then moving forward, we see that we have e to the I pi times 1 plus 2n x divided by I pi times 1 plus 2n, like that, right? And this is evaluated from 0 to 1, right? Now, next, I don't need all this junk, so I suppose I could erase. All right. So coming over here, next, when we plug in 1, remember we're substituting for x, then we get e to the I times pi times 1 plus 2n. But we said that that's equal to -1. So when we plug in 1 for x, we get -1 over this denominator. I won't write this denominator. I'll call it blah for now, because I imagine I'm going to get another denominator of blah. Okay, and then we write a minus sign and plug in 0. When we plug in 0, we get e to the 0, which is 1, right? So we had a minus sign, and then now we have 1 over what? 1 over blah. Okay, so my suspicion was right. Blah was going to be involved. Okay. So then the answer is going to be -2 over blah, which is -2 over, it's going to be I pi times 1 plus 2n, right? Now, here, we know we can't leave our answer like this. We have to get rid of the I in the denominator, so we multiply by I top and bottom. And so we're going to get -2 I over, and then it's going to be, well, I squared, so that's going to take care of this negative in front of the 2. So the I is gone from the denominator, and we just get pi times 1 plus 2n. Yeah? Okay, cool. So this is my final answer to that. And I hope you enjoyed this, and lots more to come. Keep watching. Take care.